June 12, 2024. On a routine survey 3 miles down in the Atlantic Ocean, the Prometheus 10 drone caught something impossible. A tight pocket of heat inside the famously sealed wreck of the Bismarck, 0.3 degrees higher than its frozen surroundings, hidden behind nearly a foot of armor. Sensors ruled out glitches, leaving physics and 83 years of history scrambled. If the Bismarck was a closed case, what force is still working in the dark, alone on the ocean floor? Prometheus 10 began its descent just after sunrise on June 12, 2024, from a research vessel stationed in the mid-Atlantic. The mission brief was routine: survey the Bismarck's hull integrity using the most advanced unmanned platform ever built for the Hadal Zone. Every component of the drone was engineered for extremes, its titanium alloy hull rated to withstand pressures at 20,000 feet, far deeper than the Bismarck's resting place. 4 independent thrusters managed the slow, controlled drop through 15,719 feet of water, a journey that would last 2.5 hours in complete blackness. On board, Prometheus 10 carried a suite of sensors designed for absolute precision. The thermal imaging array, accurate to within 1/10 of a degree Celsius, was calibrated against deep-sea reference standards before launch. LiDAR scanned the wreck's contours, mapping every millimeter of the armored citadel. Acoustic sensors listened for even the faintest vibration, while 4K cameras relayed sharp, real-time visuals back to the surface. Each system was tested and logged, with calibration records showing tolerances tighter than any previous deep-sea mission. The Bismarck's environment is inhospitable to nearly all forms of life and machinery. At 3 miles down, water pressure exceeds 6,000 pounds per square inch. The temperature hovers just above freezing, between 34 and 36 degrees Fahrenheit. No sunlight penetrates beyond 3,300 feet, leaving the drone to navigate by sonar and laser alone. In these conditions, even the smallest equipment flaw can mean mission failure. Redundant power supplies, shielded data lines, and automated error correction routines were built into every subsystem. For decades, the Bismarck has been considered fully explored. Previous expeditions mapped the wreck in detail, confirming the ship's final moments and the extent of battle damage. But the Prometheus 10 team approached the site with a new level of scrutiny, trusting their instruments to reveal any deviation from the expected. The data stream was stable, every reading within expected margins, until a sudden spike appeared on the thermal sensor array. The drone's systems flagged the anomaly immediately, a heat signature that could not be dismissed as error. In a world where the laws of physics are enforced by crushing pressure and constant cold, the instruments left no room for doubt. Something inside the Bismarck was still active. At 03 hours, 17 minutes, 42 seconds mission elapsed time, Prometheus 10's thermal imaging system registered a temperature spike that defied every expectation. The anomaly measured just 0.3 degrees Celsius above the surrounding steel, an almost imperceptible difference, but in the deep ocean, even a fraction of a degree is significant. The heat source was pinpointed behind 320 millimeters of armored plating, buried in the Bismarck citadel. This section of the ship was engineered to resist the most punishing blows of naval warfare, its thick steel walls designed to keep out fire and flood. Yet now, decades after the guns fell silent, an unexplained warmth radiated from within. The Hadal Zone enforces its own rules. At nearly 16,000 feet below the surface, water temperatures hover just above freezing. Any object that comes to rest here, metal, bone, or wood, quickly surrenders its heat to the abyss. The laws of physics dictate that nothing remains warmer than its environment for long. Thermal equilibrium is reached in hours, not years. For a heat signature to persist after 83 years, something inside the Bismarck had to be actively generating energy. Engineers on the surface ruled out instrument drift and calibration error. The thermal array had been checked and rechecked, its readings cross-referenced against deep-sea standards before deployment. Chemical corrosion, rust reactions, even residual battery charge. None could account for a steady, localized hotspot in a compartment sealed since 1941. The anomaly was not diffuse, not a product of slow decay. It was sharply defined, confined to a space no wider than the chamber's walls. The armored barrier itself told a story. At 320 millimeters thick, this plating was the strongest on the ship, designed to protect the most vital systems. No known natural process could heat steel of that mass in such an environment. The team annotated the thermal frame, marking the precise coordinates for further investigation. The data demanded a closer look at the structure itself. Something behind that wall was defying the ocean's grip, holding on to warmth where none should exist. The next step was clear. Examine the hull for any sign of mechanical disturbance, any clue that could explain the impossible. LiDAR scans swept across the armored citadel, reconstructing every contour of the Bismarck's hull in three-dimensional detail. The point cloud revealed a subtle but unmistakable deformation. The steel plating in one section bowed outward by 2 to 3 centimeters. This was not the jagged rupture of battle damage, or the soft sag of decades underwater. Instead, the curve was smooth and uniform, as if something inside the chamber had pressed steadily against the wall for years. The magnitude of the warp stood out immediately. Naval blueprints called for the Citadel's armor to withstand impacts far greater than any internal force. Yet here, the hull had yielded, not to torpedoes, but to pressure from within. A materials engineer from the surface team examined the scan overlays, tracing the deformation with a practiced eye. Weld seams along the affected section were thicker than standard, built up by nearly 20% compared to the rest of the ship. The original construction logs specified a uniform bead, but this segment had been reinforced as if the builders anticipated a need for extra strength. Each weld was clean, dense, and showed no sign of post-sinking corrosion or repair. The engineer pointed out that such over-engineering would have required special authorization, likely from outside the shipyard's normal chain of command. The direction of the bowing told its own story. At this depth, the ocean exerts a relentless inward force, over 6,000 pounds per square inch. For the hull to deform outward, the pressure inside the chamber had to exceed the crushing weight of the sea. That meant the compartment was not only sealed, but actively resisting collapse, maintaining its own environment against all odds. The reinforced welds and the smooth arc of the plating suggested a deliberate effort to contain something powerful or volatile. As the scans continued, the engineer flagged a faint irregularity along one seam, a thin, translucent film that seemed to glisten under the drone's lights. It was neither rust nor marine growth, but something else entirely. The team logged the location for sampling, knowing that the next step would require a different kind of analysis. For now, the evidence was clear. The chamber was not a passive relic, but an active structure, holding back the full might of the Atlantic for more than 83 years. The sample arrived at the Geomar laboratory in Kiel under strict chain of custody. Tamper-proof vials, logged at every handoff, preserved the integrity of the clear, gelatinous residue scraped from the Bismarck's armored seam. The lab's lead chemist, Dr. Ulrike Brandt, began with a basic microscopy survey. No cells, no organic fibers, just a transparent matrix with a faint metallic sheen. Under polarized light, the substance revealed a uniform structure, lacking the randomness of natural gels or the telltale inclusions of marine biofilms. Brandt prepped aliquots for mass spectrometry. The results were immediate and confounding. The dominant signature belonged to a class of silicone polymers unknown before the 1960s, long-chain molecules interlaced with lithium compounds. The lithium content was unusually high, not in the form of simple salts or oxides, but as part of complex, engineered molecules. No wartime German patent or industrial process matched the profile. The gel's backbone chemistry more closely resembled aerospace damping fluids developed decades after the Bismarck sank. Pressure response tests followed. The team subjected the gel to simulated oceanic conditions, ramping up the pressure to 6,000 pounds per square inch, while chilling it to 2 degrees Celsius. Instead of freezing or shattering, the substance thickened, becoming more viscous as the force increased. This behavior, known as shear thickening, is rare even in modern materials. Most gels become brittle or break down under such stress, but this sample resisted flow, forming a nearly solid barrier. When the pressure was released, it returned to its original state, unchanged. Chemical mapping ruled out biological origins. No protein chains, no DNA, no microbial residue, just pure acellular synthetic polymer. The lithium-silicone network was stable, resistant to both corrosion and deep-sea mineral intrusion. Brandt described the material as a smart fluid, engineered to adapt to catastrophic conditions. The presence of lithium suggested a role in energy storage or regulation, perhaps as part of a battery or dampening system. Yet the formulation was decades ahead of anything documented in 1941. The lab's findings raised more questions than answers. Why would a sealed chamber in a World War II battleship contain a pressure-adaptive gel with a chemical signature from the future? The material's properties hinted at a deliberate attempt to isolate and protect whatever lay inside the compartment. Each test result pointed back to the same conclusion. The chamber was not a relic, but the product of advanced engineering, designed to function and endure against the full force of the Atlantic for generations. 9 hours into the follow-up dive, Prometheus 10's acoustic sensors picked up a series of sharp, deliberate pings. The data stream showed 3 short bursts, 3 long bursts, then 3 short bursts, precisely matching the Morse code for SOS. Each sequence was separated by a pause of 62 seconds. The rhythm was so steady that the spectrogram revealed millisecond-level precision, far tighter than any natural oceanic sound. The pattern repeated 4 times over 6 minutes, then fell silent. On the surface, the acoustician on duty isolated the signal from background noise and ran it through frequency analysis. The amplitude and timing were consistent, showing none of the drift or irregularity typical of hull stress or marine life. The transmission's mechanical regularity stood out. Every pulse, every pause, was measured and repeated with the accuracy of a laboratory clock. The team cut the drone's thrusters to eliminate any chance of interference from the ROV itself. The signal persisted, unaffected. A military technology historian reviewed the transmission logs and cross-referenced them with wartime naval codes. In standard German naval practice, a 60-second interval in Morse signaled a vessel in the process of sinking. But an interval of 62 seconds was different. It was an obscure code reserved for a specific emergency. The vessel was sealed, cargo intact, awaiting retrieval. This interval was not documented in public manuals but appeared in classified communications protocols, uncovered after the war. The historian noted that such a code would only be activated by a system designed to survive total loss of power and crew. Attention turned to the question of energy. The Bismarck's original electrical systems were destroyed by flooding and fire on May 27, 1941. Emergency batteries of the era, based on lead-acid chemistry, could operate for a maximum of 48 hours under ideal conditions. Decades of immersion in salt water would have corroded every terminal and cell. No known 1940s battery could function after 83 years in the deep. The possibility of a natural acoustic phenomenon was ruled out by the signal's precision. The only plausible explanation was an automated system, powered by a source beyond anything available to wartime engineers. The spectrograms and logs from Prometheus 10 were archived for independent analysis. The evidence was clear. A sealed chamber inside the Bismarck had broadcast a structured, coded distress call in 2024, long after every conventional power source should have failed. The chamber's message was unmistakable, its origin impossible to reconcile with the technology of its time. Clara Hennis first encountered the discrepancy in the Bismarck's crew manifest while reviewing archived provisioning logs from Hamburg, dated early 1941. The official roster listed 2,221 men, but ration orders consistently covered supplies for 32 additional personnel. Their names never appeared in naval records, survivor accounts, or casualty lists. Instead, the logs listed only their employers, Siemens, Telefunken, Lorenz, and Schuckert, firms at the forefront of wartime electronics and engineering. These men were not sailors. They were technical specialists, brought aboard for a purpose that remained off the books. A memo dated February 18, 1941, stamped with the highest secrecy classification, referenced a detachment assigned to Compartment B, a space located between frames 98 and 102 on the Citadel's lower deck. The language was precise. Operations in this compartment would bypass the captain's authority and report directly to Berlin. The memo outlined a blackout protocol with independent life support, isolated power, and a standing order that the chamber remain sealed, except on direct command from the capital. The existence of Compartment B was not acknowledged in the ship's blueprints or after-action reports. Its only trace in the historical record came from internal correspondence and supply forms, documents never meant for public or even military scrutiny. Hennis noted that provisioning for these 32 men stopped abruptly on May 19, 1941, the day the Bismarck sailed. No death certificates were issued. No family received official notification. The paper trail ended as the ship left port, suggesting the men's presence was intended to vanish along with the compartment itself. The absence of exit hatches in the drone's scans and the orientation of the door bolts, engaged from the inside, implied that whoever occupied the chamber did so willingly or under orders that left no alternative. The bolts were designed to require manual locking from within. Once engaged, the compartment could only be opened by someone on the inside or by breaching the armored bulkhead from outside, a task nearly impossible at sea, and now at the bottom of the Atlantic. The chain of secrecy was deliberate, enforced not just by protocol, but by the physical structure itself. The specialists' employers were known for pioneering radar, cryptography, and advanced power systems. Their disappearance, coupled with the compartment's blackout status, suggested that the chamber's true purpose was to preserve technology considered too vital to risk capture or destruction. The evidence pointed to a wartime decision made in the shadow of catastrophe, one that valued the survival of knowledge and machinery above the lives of those sealed within. For Hennis, the discovery was not just a historical puzzle, but a human reckoning. The missing 32 were erased from history by design, their fate bound to a chamber engineered to outlast the war, the ship, and even the memory of their existence. The compartment order was not an accident of bureaucracy, but a calculated act, one that left a silent legacy, locked away in steel and secrecy, waiting for the world above to remember what had been forgotten. Today, the wreck sits silent, its secrets sealed by treaties, technology, and time. As deep-sea exploration accelerates, the line between honoring history and unlocking peril grows thinner. The Bismarck's hidden chamber reminds us that some boundaries exist not just for preservation, but as warnings. The real challenge is not what we can uncover, but what we choose to disturb. What would you do if you held the key?